Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or building your CI pipeline, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to pythonpodcast.com/conferences to learn more and to take advantage of our partner discounts when you register. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host as usual is Tobias Macy, and today I'm interviewing Adam Kelly and Windel Bouwman about RustPython, a project to implement a new Python interpreter in Rust. So, Adam, could you start by introducing yourself?
Hi, I'm Adam Kelly. I'm very much sort of a programming language enthusiast, which is sort of how I got into the world of implementing a Python interpreter. Self-taught basic on a ZX Spectrum, got into Python in 2006, spent 12 years doing sort of trading systems, got very into functional programming languages, and very enthusiastic recently about Rust.
And Windel, could you start by introducing yourself?
Yeah, sure. My name is Windel Bouwman. Yeah, I'm an open source fan. I like open source and hacking with Python. So I've been working with Python for some time now. And last year I wanted to do something with Rust, and it looks pretty good. So I like the language as such. And by day I'm a software engineer. So working with mainly C and C++ at the moment.
And going back to you, Adam, do you remember how you first got introduced to Python?
Sure. I think I remember people talking about it way back in 99, and I wish I'd taken the time to learn it then. And then in the gap after my PhD, I needed a new language to learn, and Python seemed like a great one to learn, and I was very enthusiastic from it from the moment I started learning it.
And Windel, do you remember how you first got introduced to Python?
No, I don't. I actually don't remember. I think it is a long time ago, but I think I remember I was a little bit surprised by this white space thing. First I was not really a fan of it, but now I actually am a fan, so yeah. That was kind of new to me.
And so in the process of working with Python and exploring other languages, there's this project that you've both become involved with called RustPython. So can you describe a bit about what it is and how it got started?
Yeah, sure. I can describe it. So RustPython is basically a implementation of Python written in Rust. I actually started it for learning Rust, so to say. I googled it. I could not find any other project doing it, so I thought I was the first, but I was not. And then I contacted Xing Liu, who also started with the same idea. And we created a repository on GitHub. And that's how it started going. And at the beginning I thought, I don't know how hard it will be. Actually, it's a lot of work. So I expected that. Yeah, turned out to be true. I think it's now 1 year later or something.
I discovered the project at EuroPython last year when I saw Windel's talk. I'd spent a long time, I want to learn a new language, I'll implement a scheme interpreter. Drew me to the project, so I was like, I want to get involved in this. Got stuck into making classes work at that point.
And before we go too much further, can one of you describe a bit about what the Rust programming language is for anybody who isn't familiar with it, and some of the reasons why you might want to build an interpreter with it?
Sure. Rust is a low-level programming language in terms of it's trying to compete performance-wise with C++ while providing really great memory safety. type features. So you don't have a garbage collector, but at the same time, you don't need to worry about manual memory management. Rust at compile time can track who owns each piece of memory and ensure that you're not doing anything bad, like using memory after it's freed.
Yeah, maybe one thing to add is Rust has really a lot of syntax features. So it's like in C you have while, if, switch case statement maybe. That's it. In Rust there's really a lot more, I feel.
Yeah, it's really a language that's trying to bring in a lot of modern programming language features which have been developed in other languages, and it's really it has everything you could possibly want language.
Yep.
And some people would say that that's the same with C++, but often it's meant as often it's not meant as a compliment. It's meant as a sort of denigration of the language, that they're just throwing everything in with the kitchen sink. But my understanding of Rust is that there's been a lot of upfront design thinking about how it all fits together and what the overall goals are of the language, rather than just cramming every new feature that somebody might ask for.
I think that's very fair. I know earlier versions of the language had garbage collection and green threads, and they took them out because they decided to refocus on making it perform as well as they could.
Yeah, I think also Rust has the benefit that they can start with a clean slate, so no legacy, whereas C++ of course has I think 40 years of legacy, all the way back to early C maybe. So that's a good thing. Also there's dependency manager with the cargo tool, unit test, style checking with what's it called, Rust format, which is really good.
And so can you discuss what your overall goals are for the RustPython project and what's involved in implementing a fully compliant Python interpreter?
So that's a good question. So I think the goals are not really set in stone yet, I would say. It's still starting, the project is still in the early phase. I think we even have discussion within the group where we should go with this project. I don't know, is that correct, Adam?
Yeah, for me, it's very much, implementing an entire Python interpreter is an absolutely huge task. So I think the only way I can come at it as a project reasonably is I'm here to learn Rust, it's really fun learning all the ridiculous details of Python. If it can become something practical and useful at the end, that would be great. But in the meantime, I'm very happy as a learning project and a chance to really get into deep into what's involved in implementing a real language.
And I know that the Python language has a fairly well thought out and well expressed language specification, which isn't always the case with other runtimes. So I'm wondering, what are some of the biggest difficulties that you're finding in the process of trying to match some of the specification as far as your interpreter?
I think we struggled a lot with the dictionary type, right? You implemented it recently, Adam, that we support now all types as keys. That's maybe not a hard part actually.
It's a really complicated language is my take on it. It's a really simple language to use, and that's what makes it great. But when you dive in, the simplicity as a user comes from these really complicated interlocking pieces. So resolving attributes on classes has something like 5 cases you've got to iterate through. And then if you're resolving an attribute on a type, it's slightly different. And I love exploring those circles. So type is a type, object is a type is an object. They both have dictionaries, sort of like this puzzle of interlocking things. And everything is modifiable is the other thing. So you can change the class of a class at runtime. You can replace a class's an object's dictionary. And I think it's a very open question how much of that we will eventually support, because some of that is sort of undefined and you're just looking at the way CPython works, and some of it is defined and you have to implement it.
And in the overall process of building your interpreter, how much of that involves just going through and trying to parse the CPython implementation and figure out what those different bits of C code are doing, and then try and replicate that functionality in a different language?
I sometimes looked at the CPython code. I also got a reference from MicroPython codebase, which is a little bit simpler in some cases, I would say. I also looked at the PyPy implementation in the Python interpreter written in Python. So because that's quite easy to read, so then you get an idea how some part of the language really works. At least that's the references I took to Peak. And sometimes it's pretty obvious what has to be done. So no need to reverse engineer or translate existing C code into Rust code.
I quite like playing with CPython. That's my starting point, is like poking CPython and trying to find out what it does. I should probably be looking at the CPython code more. I think we all have sort of a different way of coming at these problems. But between sort of having an implementation you can try and match, having the CPython code, and having various specification docs and blog posts, you can sort of work out what needs to be done.
And can you walk through a bit of the overall development cycle of figuring out what's the next feature that you're going to try and replicate, or what's the new capability that you're trying to add, and how you manage the overall roadmap? And I'm also particularly interested in terms of the early days of the project of just getting something that would even compile just the simple hello world example of Python, and how you went from 0 to that point, and then from that point to where you are now.
Yeah, all right. So the first thing I tried was parsing some example snippets. Print hello world, for example. That's actually the piece of code I started with. So it's a simple Python file with only 1 or 2 lines containing a single snippet of syntax. And I started with the parser part, trying to parse that part of the code, and then adding the translation to bytecode. That was done later on. So that was really in the beginning. I think the current way is what I try when I'm looking for new things to implement in this is taking a piece of code, running it, and see where it fails, and then try to figure out why it fails and a way to fix it. And recently I experimented a little bit with the Ouroboros library, which is a Python library, standard library, just going over all the Python files and see if those files parse correctly, for example. That's my take on it.
Very much similar, I think. When I first came, I think the first thing I tried was, let's define some functions and execute them. And then I found they worked, but there was no arguments. And then from there, classes is the next thing. And then that got me into how do classes work? And from there, I think I've got stuck into trying to make sure that all of that machinery is right. So we have dictionaries and attributes, and looking at how all of that stuff interacts. So I've done quite a bit of work on scopes. And then there's quite a lot of optimizations in CPython to make sort of local variable name resolution work fast, to make sure magic method lookups are fast. And so I've been thinking a lot about making sure that machinery works. But I think we've done very well, because we've had a lot of great contributors who've come at the project from different angles. So we've had somebody who's come in and made sure that our internal APIs are sensible and that we can define Python functions in Rust easily. We've got a very nice API from that. And then we've got other people who've come in and gone, well, it'd be really cool if we could run this on the web with Wasm. So I think we've got a lot out of different people coming at the projects from different angles. And because we're just all doing this in our free time, it's got to work like that. It's got to work like, let's attack the bits that interest us.
And in terms of the overall roadmap, I don't know if you have it sort of like well defined as to what pieces you have and what pieces you don't, but I'm just curious, at least from a gut feel, how far along you are in the overall process of getting an interpreter running that is able to implement at least the majority of Python code.
We now have complete syntax, I believe, and most of the core of the language works. There's I think a couple of things. We've been looking at sort of local and global keywords. Nobody's ever mentioned async, so I suspect nobody's looked at that.
Not yet, no.
And then the core types are coming along rapidly, so making sure that we have all the methods on dictionaries and sets and all of that. And then the standard library is the huge piece behind that.
Yeah.
Yeah, I know that there's at least a decent amount of the standard library that's actually implemented in Python, but there's also another set of it that is implemented in C. So I'm curious how much of that overall effort needs to be replicated in Rust, or if you're just looking to libraries such as what you mentioned, Windel, with Ouroboros, where it's just a pure Python implementation of the standard library, and just the overall tack that you're taking on that front.
Yeah, it's a really interesting case, because if you go from the Python libraries, like for example the unit test part of the standard library, I think it's all written in Python, so that could be simply copied from CPython or maybe PyPy or another implementation. But the further you go, down to some core modules. Some of them are implemented half in C, half in Python, and then it gets really interesting. So I actually don't know exactly how we're going to tackle this. It would be good if there was some shared repository between all Python implementations, which contained all the pure Python standard library functions and files. But there's no such thing. So yeah, that's the challenge. I think that challenge will come rather sooner than later.
And I know that the primary goal of any project like this is to be able to maintain feature parity with the reference implementation, but in some cases it can also be important to maintain bug parity. So I'm wondering if that's something that you have looked at all, where you want to ensure that some edge case in the CPython interpreter that operates in an undocumented way also operates the same way in Rust. One of the more famous examples being that dictionary keys in certain cases were implicitly ordered before they were made explicitly so, and people relying on that case.
Dictionary keys insertion order is we have implemented it that way. That's now the order is guaranteed, right?
Yes, that's correct.
So we have covered that, but for all other going into question of bug parity, my opinion would be not to go for bug parity, but just implement it in a correct way. So not copying bugs. But maybe later that will change, because I think it depends on what we want to do with the project. Do we want to be at the drop-in replacement for CPython, or do we want it to be another Python implementation? I think it's not yet decided, right?
Yeah, I think so. I think it's something that people within the project have quite different ideas about and are coming at from different directions. So it'll be interesting to see how that plays out. And you very quickly start finding cases where CPython does something strange. You're like, do we need to implement that? Sometimes it's quite fun to figure out how to implement it. But so I was looking, because dictionaries have just gone in, I was looking at dictionary iterators and what the rules are for if a dictionary changes while you're iterating it. And there's a little bit of freedom there in what you're allowed to do versus what CPython does. Quite fun.
And another question that I have in terms of compatibility with CPython is the idea of libraries, particularly ones that rely on C extensions, and what your plan is as far as that level of support, or if you're just aiming for pure Python implementations similar to what PyPy is targeting.
So I know a little bit about the amount of work that PyPy have had to do on this. I mean, getting fast NumPy to work there has been a hellish project, and I think building a compatibility layer such that extensions that expect to be talking to CPython can talk to the API. Hopefully some of the work that PyPy has done can make that easier, so there are better interfaces there for things, and maybe we can piggyback on some of that. But I think there's a huge amount of work if we want to get that far with the project.
I think we will do that in the end, and hopefully some extensions that are now written in C will be rewritten maybe in Rust, and then we don't face this problem anymore. Maybe that's the take on it.
It's an interesting potential application that if more people are using Rust and they want to have Rust-Python interactions, then maybe at that point RustPython has a use.
Yeah, I think we will probably first support extensions written in Rust, right?
I would expect so, yes.
I think that would be easier.
And in terms of your overall developer community that you've built around it, I'm curious about how many people are actively involved with the project and how much interaction you have with the core Python developers as far as just being able to get design advice or answer questions about various edge cases and the implementation.
I think there's now a group of, 6 or 7 people being really actively working on this. I guess something like that. Personally, I didn't have much contact with the CPython developers. I don't know about you, Adam?
No, I haven't yet. I think probably as we get more complete and we start to hit really, really hairy edge cases and maybe get more into the bug parity, it'll become more relevant. But at the moment, I think we're working in areas that are pretty well understood, so we haven't had to.
And also in terms of your overall development pattern of building RustPython, I'm curious how much of the work requires implementing things from scratch and how much you've been able to lean on the Rust community of libraries and crates for being able to pull in functionality.
Yeah, that was one of the reasons actually why I wanted to try this out, because in Rust you already have, for example, Unicode, strings, it's all working. So no need to do weird things with C and Unicode and these kind of things. Also, there's a regular expressions module, and I think the regular expressions model is one of the modules that actually uses a Rust package. So in that sense, it's the regular expression module that you import is really a sort of a proxy to the regular expressions engine, and that's a Rust package. So it was a matter of adding it to the project and running the correct function, and it all worked. So that was really good. That was actually one of my hopes that I had with this project, that since there's so many libraries already written in Rust, that we could leverage those libraries. So I'm also curious about other standard libraries that maybe also could benefit from this. I think, for example, the I/O library, dealing with files and these things, and maybe the encodings. So going from different text encodings and these kind of functions. I think there's good possibilities there.
I think at some point soon we need to tackle the questions around concurrency, because I think that's quite an interesting case. It'll be very interesting to see what tools Rust provides us with there. The GIL is always one of the things that comes up, and at the moment it's not an issue because we don't support threading.
So we don't have a GIL yet.
We don't have threads yet.
No, exactly. Yeah, I'm curious how that will work out.
But I'm hoping that, while it's not necessarily an easy thing, there's a reason CPython has the GIL, that Rust safety features will really help when it comes to attack concurrency, and that we might be able to do something good there.
Yeah, I think the object model we now have, I don't see any reason why we should have something like the GIL. But on the other hand, I think we will find out when we implement something like the threading module. We'll probably find out. I'm curious how this will go.
And in the other direction, I'm also curious if there have been any pieces of work that you have put into RustPython that you've been able to extract out into reusable libraries for other people in the Rust community to take advantage of.
I don't think we've done that, right?
No, I don't think so. It's an interesting question to think about whether we have anything yet that would be useful like that, but nothing comes to mind.
I think probably the Python parser, it's a separate crate at this point, so it could probably be reused in other projects where you need to deal with Python code and only analyze the Python code, for example. So going from Python code to an AST, that could probably be reused as a separate package. But the rest of it, it's really one crate actually.
And the other question is in terms of the overall binary size of the compiled interpreter, if you have put any thought into trying to minimize that at all, or if the main focus right now is just getting everything working and then dealing with that as a later optimization if and when it becomes necessary.
I think the current goal is to get it working at all, and size is not really an issue. But I think we can also compile it for the web. Then size is always an issue. But I think it's a good thing to go for code size reduction, or at least keeping it small, because for the web we can use it, but also for microcontrollers it's maybe also interesting. So you could go the embedded route with RustPython as a sort of next to MicroPython. Of course it will be larger, but I don't know how much. I think the current binary is 6 megabytes or something. I can check.
You did have to do some work to get the binary size down for the WebAssembly side of things, didn't you?
I didn't do that part of the WebAssembly.
Okay, fair enough. I saw something going through, but I don't remember the details.
Yeah, I did one optimization in the parser part. So we used the parser LR pop it's a Rust crate. It's a Rust parser generator, and I did a trick there to reduce the generated parse tables. I think that saved 1 megabyte or something, or half a megabyte of code size in the WebAssembly build. Still, it's rather large, but it saved some.
And so, as you mentioned, one of the other benefits of using Rust for this type of interpreter is that it does have a WebAssembly compilation target. And so I'm curious if you can talk through a bit of some of the vision of how WebAssembly will be able to support writing client-side Python, and just your overall experience of working with WebAssembly in this RustPython project.
Maybe I can describe WebAssembly first in a bit.
Sure.
Yeah, so WebAssembly is an idea to write code in any language you like and then compile it to WebAssembly and then be able to run it in the browser. Whereas previously people were really, when you develop an application for the browser, you have to do it in JavaScript. And of course JavaScript is good, but not everybody likes the language itself. And precursor of WebAssembly was ASM.js, which was a subset of JavaScript. And then compilers were created to compile, for example, C code to this subset of JavaScript. And then you could run arbitrary C code in browser. But still it was JavaScript. So then the next phase was WebAssembly, which is really a binary format, which could also be targeted by compilers, for example, going from C to WebAssembly. And then you can run C code in browser. And Rust also has this option to compile from Rust to WebAssembly, which means effectively that if you have a Rust program, you could compile it to WebAssembly and then include it in your web page and load it and run it in your browser. And that's actually what has been done with RustPython as well. In the demo page, you can run the RustPython interpreter inside the browser, really at the client side. So there's no communication going to a server where a Python process is run, but it's all done on client side, which is rather interesting. And there's some pretty good packages and tools supporting to build a Rust application and compile it to WebAssembly. Unfortunately, I didn't set it up, and you were also not involved, so we're not really involved in how we did that. But I was able to reproduce it locally on my machine, so that's something.
It's a great aspect of this open source model, though, that we built an interpreter, and then some other people have come along and stuck a web page in front of it, and now compiles, runs in the browser, and if you go to the page, you get a nice interactive Python terminal in a web page. And
it was actually one of my more evil plans to lure more people into this project, because I thought, hey, there's Rust and you can target WebAssembly. We have lots and lots of front-end developers, so there's lots of people working with this WebAssembly Rust thing. So it has to be popular. So probably, maybe we can get some attention and have some help of those of other people who maybe come from this space. And maybe it worked. I don't know.
Yeah, I'm also interested in the types of applications that this might enable, as far as being able to use Python in the browser context natively rather than through some sort of transpilation layer, or from trying to load a gigantic binary into the browser, which it sounds like is still a little bit the case with RustPython, but down the road you might be able to minify it a bit more.
I don't know. Yeah, I hope we can minify it, but we will have to look into it. Maybe we can split it in some way that if when you import a module, that you download it on the fly. One application that has already been built is the Pick It Up game engine. It is built on Quicksilver and RustPython. Quicksilver is a game engine written in Rust, and it is then combined with RustPython, so you can write games in Python and run them in the browser. So that's actually one example of what you could do. Still, what you mentioned is true. You have a really bulky binary that you have to transfer over the web, and so it is not really bandwidth friendly in that sense. I think the binary is still 3 megabytes or of WebAssembly what you have to download.
Another potentially interesting application is Python is often used as a language for learning. It's quite a learning language. So there might be applications around people who want to just do that for learning Python interactively without the need to download and figure out how to install Python locally. There might be some interesting sort of applications that could be built there.
And on the web front too, I'm also curious if you have done any research as far as being able to minify Python code similar to what happens with JavaScript, and also how the packaging story would work out for being able to bundle up your Python code for delivery to a client-side browser.
I don't know if I think we haven't looked at that, at least not that I know of.
No, I did Google just before our conversation and found PEP441, which handles building zip archives from Python code, which is quite interesting. I don't know whether you want to ship a full zip management to the browser. Might just make our interpreter even bigger, but it's interesting that exists.
Yeah, we still need the zip module.
Yeah.
Probably we can reuse some Rust crate that does zip, so that's good.
Yeah, I know that there are projects such as PEX for being able to bundle up an entire Python environment as a zip archive for delivery to the server side, but I'm curious how that would manifest on the client side because of that pressing desire to try and keep the binaries and the deliverables as small as possible.
Yeah, that's certainly going to make it a real challenge. And you're competing with JavaScript is very established and a lot of work has been done in this space. So there's a lot of catching up to do to get there.
And in terms of your overall experience of working with the RustPython interpreter and trying to replicate functionality of other interpreters, I'm wondering what you've each found to be some of the most interesting or challenging or unexpected aspects of the project.
The thing I'm currently facing is the global non-local keywords. I was a little bit surprised how that should be implemented. I still don't fully understand how it should be done, but I thought those things would be simpler. But yeah, it was a bit harder.
I think a lot of sort of understanding the complexity of the internals and how many moving pieces there are. I'm quite interested at the moment. I'm looking at starting to look at slots and how class attributes can be accessed. And I think there's quite a lot of exciting optimizations there.
And are there any particularly interesting uses of RustPython that you've seen beyond just standard Python development, or anything sort of unexpected as far as the directions that the project has taken or ways that the project is being used?
I don't know if it's used actually. I only see one use case in the Pick It Up game engine, but for the rest, I don't know. Also wouldn't recommend actually to use it at this point. Since it's still, I don't know. It's not really usable, I think, in an actual application, I would say.
Yeah, I think once we're a bit more complete, it will start to get to the phase where we can find uses for it or find things where there's reason for people to come and use it. But at the moment, it really is a tool for people who are interested in learning about how a programming language interpreter works, how it fits together, how Python.
And looking forward, what do you have planned for the near to medium future of the project as far as goals for utility or specific features that you're looking to implement, or just overall community engagement?
I think we've had a lot of flux recently in terms of getting all our internal APIs right. So I think there's quite a lot of refactoring work in getting all of that in. Moving on to more interesting things, I've mentioned the optimization. I think starting to look at how fast we are. I think when we measured it, we were something like 17 times slower than CPython, which I thought was not a bad result for a naive implementation. The other thing I really think we should have a look at sooner rather than later is the concurrency stuff, because that's going to impact a lot of things. And it's also a good advert if we can get a GIL-less Python without a massive slowdown, then that will be a great thing to achieve. Garbage collection is a fun project as well that's come up. We currently don't have it.
Yeah, and maybe I think the standard library is also one interesting puzzle to solve. I'm looking forward to having a unit test module in the standard library. I think that's a good goal.
It'll be really nice once we have unit test, we can start running CPython test suites against our interpreter and see just how compatible we are.
And your point of the garbage collector is interesting too. I'm curious if you have put any thought into whether you're going to try and take a different approach to the overall design, or if you're going to stick with the reference counting and generational garbage collection.
So currently we use reference counting, which Rust provides for us. So we can use Rust's internal implementation of reference counted pointers. So we have that type of garbage collection there already. There's nothing in order to deal with with cycles. So obviously we're leaking there. Somebody has had a look, and there are garbage collectors written in Rust. So it'll be very interesting to find out whether or not we can just bring one of those in and take advantage, as was mentioned, of Rust's large ecosystem of libraries. If we can just take a garbage collector off the shelf and use it, that would be very cool.
And what do you think are the risks that you can anticipate or that you foresee that could potentially derail the project before you get it to production readiness?
I don't know. I don't, maybe that it will take a long time to complete it. Or maybe some disagreements about how we should implement things, and that the project will be forked in two. But at the moment, I think we're still heading in the correct direction. So or more or less in a good direction. So I don't see any risks yet, except that it will be a lot of work. And maybe in the end, one risk would be that we copy the standard library, and we will have to maintain compatibility with the CPython implementation.
I think the sheer scale of the project is very much the biggest risk. It's a lot of work. And at the moment, we lack a clear purpose beyond it's very interesting. So the other risk is we get to a point where we've done all the interesting work and there's no use for it.
Yeah, maybe that's one of the risks, that we don't have a clear goal. Yeah, there's some fake goal. We want to build this, but not really set in stone with milestones and these kind of things. So I don't know.
And as far as help from other contributors or from the community, are there any specific areas that you're looking for people to join the project and add their own opinions or feedback or contributions?
I think we're always on the lookout for people adding functions to the built-in objects, for example. I don't know how percentage-wise how far we are. We have a script which checks all the methods which should be present. So in theory, it should be possible to get some percentage there on how far we are. But I think it's good starting issues. It's relatively easy to do, and it's really a lot of work. So I think there we really are looking for contributors in this area.
And are there any other aspects of the RustPython project or your efforts of replicating the CPython runtime that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, maybe one thing to mention is the JIT, the just-in-time compiler. So PyPy is a really fast implementation of Python since it has a JIT. So I think one of the opportunities we have with RustPython is also to add a JIT compilation phase in one way or another to make it go faster. I don't know how it will work yet, but I think there's JIT projects. There's a Holy JIT project. It's a Rust project for creating a JIT in a way. It should work. So we have to see how we can combine it with the RustPython interpreter.
The whole area of performance is going to be very interesting once we can get stuck into it. I think so far the emphasis has correctly been on getting a complete interpreter. But we're going to need to set up test suites to sort of monitor performance and then get into that nitty-gritty of making it fast.
All right. Well, for anybody who wants to get in touch with either of you and follow your progress on the project or possibly add their own contributions, I'll have you add your preferred contact information to the show notes, and I'll also add links to the GitHub project. And so with that, I'll move us into the picks. And this week, I'm going to choose the group Oysterhead. It was a super group consisting of Les Claypool from Primus, Trey Anastasio from Fish, and Stuart Copeland from The Police. And they did one album, one tour, and then they split up and never wanted to talk to each other again. But the outcome of that was a very enjoyable album, definitely worth checking out. So with that, I'll pass it to you, Adam. Do you have any picks this week?
So one thing I've come across recently that I've really liking is FZF, the fuzzy finder, which I find very useful for sort of leaping to files in source code. They've also made bash history far more usable, and it sort of integrates itself in lots of useful places. It has support inside Vim as well.
And Windel, do you have any picks this week?
Yes, the progress bar for Python. It's a package, Python package, TQDM. I really like it. You have a for loop. You decorate it with this library, and then you have a progress bar in your for loop. So, yeah, I think it's one of my favorite packages for the last half year that I found. It's really fun.
Great. Being able to have some understanding of how far along you are in a process can be invaluable at times. And I'll also second your pick of the fuzzy finder. Being able to just type in portions of strings and find something useful out of it is always very helpful. So I want to thank the both of you for taking the time today to join me and talk about your work on RustPython. I'm definitely interested to see how the project progresses and possibly have another entry and another option for people who want to run their Python code. So thank you for your efforts on that front, and I hope you enjoy the rest of your day.
Thank you very much. It was great talking to you.
Thanks. Thank you.